Examples. All right. Okay. So, looking right here, remember the first thing that we do is we are going to tally up everything that we have on both sides. So we have aluminum and we have oxygen. All right, aluminum and oxygen. Okay, how many aluminums do I have on the left side? Two. Okay, two. All right. Now, how many aluminums do I have on the right side? One. How many oxygens do I have on the left? Three. How many oxygens do I have on the right? Two. Dos. All right. So, first thing I would do, normally I would balance my aluminum first. However, in this case, I probably wouldn't because aluminum is all by itself right here. And I can put whatever number I need to right there, and it doesn't affect anything else. So I'm actually going to balance the oxygen first, and I'm going to show you a little trick. So I have 3 oxygens on the left and 2 on the right. I can never multiply 2 by any whole number and get 3. Like, you can't do it. So I'm going to have to multiply both sides by a number. What you have to do here is you have to find the least common multiple. Okay? So the smallest number that both 3 and 2 would go into is 6. So what do you multiply 3 by to get 6? 2. So if you put a 2 right here, that gives me 4 aluminums. It also changes my oxygen to 6. And then what do you multiply 2 by to get 6? 3. So if we put a 3 right there, that makes this 6. And then the only thing we have left to balance is my aluminum. So what do I put right here? 4. And that's going to balance everything out. Okay? Everybody with me? Does that make sense? All right. Go ahead and flip the page. All right, look at number 17. This is on page 10. And let's tally everything up. We got quite a few elements here. We have magnesium, oxygen, hydrogen, sulfur, and that's actually it because we have those in multiple places. All right, now, how many magnesiums do I have on the left? Just 1. How many do I have on the right? Also just 1. All right, how many oxygens do I have on the left? All right, you got to be careful here. This 2 applies to everything inside the parenthesis here, so that means I have 2 oxygens, 2 hydrogens. So 2 oxygens here plus the 4 right here, that's going to give me 6. All right. How many do I have on the right-hand side? 5. All right, there I have 5. All right, how many hydrogens do I have on the left side?
4.
4, because I got the 2 right here and 2 right there, so that's 4. How many do I have on the right-hand side?
2.
Just 2. And how many sulfurs on the left-hand side?
1.
Just 1. How many on the right-hand side? Also just 1. All right. So the only thing that's out of balance are my oxygens and my hydrogens. So this could get a little tricky because I got oxygens in multiple places on both sides and hydrogens in multiple places on the left-hand side. So we'll see how this goes. All right, now, here's the thing. Okay, I'm going to kind of help to guide you here. If I can put a number in one place and affect both things that I need to change, sometimes you should try to do that. So let's say I have these 4 oxygens right here. I really don't want to change this magnesium if I don't have to, because it's already balanced. So if I look at this right here, both my oxygens and hydrogens are out of balance. What do I need to multiply the hydrogen by to get 4? 2. If I put a 2 right there, 2 times 2 is 4. That changes my hydrogens and balances it out. Also, how many oxygens does that give me right here? 2 plus the 4 that I have over here, which makes this 6. So that actually balances the whole thing. So sometimes these look harder than what they actually are. You'll get better though. All right, I'm going to teach you a little trick on 18. So, number 18. Oh, yeah. Sorry. So, the trick for this one is to look at this, all right? So, see how this has this SO4 unit right here? And it also has this SO4 unit right here? You see that? Okay. If you have something like that, this is something called a polyatomic ion. Okay? Polyatomic, what is the word, or what does the prefix poly mean? It means more than one. Okay? Poly means one. If it's monoatomic, that means one atom. Polyatomic means more than one atom. So this is an ion that's actually a unit. Okay? It travels as a unit. So SO4, it's like one thing. So up until this point, we have actually broken this down into the elements. Like up here, we did this with SO4, okay? But what we're going to do here, instead of breaking this up, if it stays together, we don't have to break this into sulfur and oxygen whenever we tally up the elements. We can just actually take it as a whole. So what we can do is tally up aluminum, tally up bromine, tally up potassium, and then just tally up your SO4s as a whole. And sometimes that makes it a little bit easier than breaking it up into the individual elements. All right, how many aluminums do I have on the left?
1.
Just 1. And how many do I have on the right?
2.
2. How many bromines do I have on the left? 3. How many do I have on the right? 1. How many potassiums do I have on the left? 2. And how many on the right?
1.
Just 1. And then how many SO4s do I have on the left?
1.
Just 1. This 4 applies to the oxygen, but the SO4 as a whole, if it's not in parentheses, I only have 1 of them. So just 1. How many do I have over here? 3. Everybody understand that? The parenthesis applies to everything inside there, so that gives me 3 SO4 units, which is called sulfate. All right. Okay. I would go ahead and just start at the top on this one. So balance out your aluminums. If I have 2 over here, what do I need to put in this slot?
2.
Put a 2. Okay. And that's going to change my aluminums to 2. It also changes my bromine to 6. All right. Now, if I have 6 bromines on the left, what do I need to put right here to be able to get 6? Put a 6. So that changes my bromine to 6. It also changes my potassium to 6. Wait, why are you confused? Wait, hold on. Let's slow down. Maddie, what's your question?
Oh, hold on, never mind. I did it wrong. I was doing it on that side. I was like, how is it not 8? But I got it.
All right, let's go back. Let's go back to the beginning where we were. So we had 1 aluminum over here on the left. So you got to put a 2 there to multiply it by 2. Okay, so 2 times 1 is 2. So that changed that to 2, but it also changed my bromine. 2 times 3 is 6. So that's why I needed to put a 6 right here to change my bromine here to 6. All right, so that gives me 6 bromine, but it also changed my potassium in the process. Okay, does that make sense? Kind of. All right. Now I have 6 potassiums on the right, 2 on the left. What do I need to multiply 2 by to get 6? 3. So put a 3 right there. That changes my potassium to 6. It also changes my SO4, which is sulfate, to 3. That's balance. If the numbers are the same right here on either side, balance. All right? Anybody lost? Have any questions? All right. Go ahead and flip the page to number 11, page 11. We're getting there. If there are, they're back there in the. Yeah, I don't think I have any more extras then. Actually, check over there on that cabinet, on the shelf. There may be some over there. If not, I don't have any extras. All right. Look at number 21. Okay, look. That hint that I just gave you last time where you can take the polyatomic ion and just treat it like one thing, that doesn't work here. Even though you have a polyatomic ion, it doesn't look the same on both sides of the equation. Like you don't have an OH group over here. It turns into water. So you can't do that hint here. You have to break everything up. So let's go ahead and do this one together. So we have lead, and we have oxygen, hydrogen, and chlorine. All right, how many leads do I have on the left?
1.
Just 1. How many do I have on the right?
1.
Also just 1. How many oxygens do I have on the left? 2. Everybody see that? That 2 applies to everything inside the parenthesis. So 2 oxygens. How many do I have on the right?
1.
Just 1. How many hydrogens do I have on the left? 3. Because I got the 2 right here and I have 1 right here. So that's a total of 3. How many hydrogens do I have on the right? 2. All right, how many chlorines do I have on the left? Just 1. How many chlorines do I have on the right? 2. All right. So lead's already balanced. I would save my hydrogens and oxygens till last here. So let's go ahead and balance chlorine. If I have 2 chlorines on the right, what do I need to put right here to give me 2 chlorines?
2.
Put a 2. 2 times 1 is 2. All right, that also changes my hydrogens. It gives me 2 hydrogens here, plus the 2 right here. So that gives me a total of 4. All right, everybody with me there? All right. Now, what do I need to put right here to give me 4 hydrogens? Put a 2. 2 times 2 is going to give me 4, and that balances that out. Or wait, yeah, it does. Sorry. The oxygen also gives me 2 oxygens, so that balances it out. Perfection. So 1, 2, 2, 1. Those are your coefficients there. All right. Let's take a look at the last one. I'm going to show you your last trick here. Okay? You stuff this in your bag of tricks. All right. So this is a combustion reaction. It's got carbon, hydrogen, oxygen in it. All right. Now, how many carbons do I have on the left? 2. All right. 2 carbons on the left. How many carbons on the right? 1. How many hydrogens on the left? 6. How many hydrogens on the right? 2. How many oxygens on the left? Only 2 on the left. How many on the right? 3, because you got the 2 here plus the 1 here. So it's a total of 3. All right, go ahead and balance your carbon first. So if we have 2 over here, what do I need to put right here? Put a 2. 2 times 1 is going to give me 2. It also changes my oxygens, however. 2 times 2 is 4, plus the 1 here. That gives me 5. Yeah. All right. Go ahead and balance your hydrogens next. So I have 6 here. What do I need to put right here to give me 6? 3, because 3 times 2 gives me 6. So that changes my hydrogen to 6. It also changes my oxygen again. So 3 here plus the 4 that we had right here, that gives me 7. All right, now, here is the trick, and you will see this a decent amount of times. Okay, from time to time, you will see this. When you have an odd number of one element on one side and a diatomic atom on the other. You see this? Oxygen is diatomic, O2, 2 atoms. Okay? I have to have an even number. Okay, I have to, because you can't multiply 2 by something and get an odd number, at least a whole number. So what we can do is this. If we save this spot, this is going to be our last thing to balance. If we multiply everything else in this equation by 2, it'll work. So multiply this by 2, that gives me 6. Multiply this by 2, that's a 4. And multiply this by 2, that's a 2. Then that's going to multiply everything down here by 2. So that'll become 4. That'll become 4. 6 becomes 12. This 6 becomes 12. And 7 becomes 14. All right? Now, what times 14, what times 2 equals 14? 7. So if you put a 7 in that spot, that changes my oxygen to 14, and now it's balanced. So that's a little trick, because you will see diatomic atoms like that quite a bit. Okay, you'll see it. So just keep that in mind. Just kind of tuck that away in the back of your mind to use if you ever see another one like that. And here's another reason why. Whenever you have a combustion reaction is always a reaction of oxygen, O2, and some hydrocarbon compound. Okay, it's a burning reaction. So it's going to be some combination of hydrogen, carbon, sometimes hydrogen, carbon, and oxygen. All right, if it's like an alcohol or something like that. So that happens a lot in those types of reactions. And just remember this little trick whenever you have to do that. Okay? Anybody have any questions? Any confusion? All right.